Okay, welcome back. We are continuing in our quest to create pretty things that look like this. And so far we've got to the point where we can draw slightly less pretty things that look like that. So what we want to do in this section of my art class is look at extending our tree to be something slightly more interesting than just a line. Let's see what that requires. At the moment, we've got nothing. We've got one helper function that does nothing other than convert angles, and then just a bunch of regular R code. Perhaps the first thing we should do is start trying to organize this a little bit better. So we'll have, let's start out with this idea that maybe we should have, let's say, at least 3 functions. So we'll have one thing that we'll call grow sapling, sapling, and that will just be a function. Doesn't take any input whatsoever, so I'll just leave that blank. And then what it does is return the sapling object. So I'll go Control X, we'll just move that code up in here, Control V, and then we go return sapling. Oh my god, I'm typing the same word over and over again. Sapling. Sapling. There we go. Okay. This is just really for my own convenience. I kind of like wrapping things up into functions wherever I can. But a kind of similar example of what we might want to do is have it draw the tree or plot the tree, right? So if we go draw a tree, sorry, what I'm trying to say is that I would like to have a function that takes a tree as its input and then returns the ggplot object as its output. So what we want to do is grab all of this junk here that is currently cluttering up our nice, pretty script, and we'll go move that, chuck that in there, delete that thing that I don't know how that got in there. And now what I've done is I've got 2 functions here. One of them relates to creating the sapling, and the other one that is the picture, the thing that returns that creates the plot, right? Which I forgot to include the return value explicitly, so I should do that. What I can do now is organize this a little bit better so that my code looks like this. Tree equals grow sapling. And then what I want to say is that pick equals, what did I call this function? Draw tree. Draw tree of tree. And then plot tree. This is kind of nice. Like, I haven't added any new functionality, but again, like, part of the point of this is why use functions? Well, let's have a look at our code now. I now have this code structured so that I've got my setup up the top. I've got my helper function defined there. I've got I think of these as the worker functions. So let's just quietly rename this now to workers. Or whatever, you know, I like to, you can do it your own way, but this is how I like doing mine. So we've got my worker functions that do the stuff that is related to the topic at hand, and then I've got one small section right at the bottom of my code where I kind of go do stuff. So that'll work. And now again, I have my code nice and neat and organized again. So it's very clear that my process is grow the sapling, then draw the tree, then plot the tree. And all of the all of the work is being done by the draw tree function and the grow sapling function, and probably at some point in the near future I'm going to start using helper functions to do the work. Okay, so what I really would like to be able to do to get my tree to look a little bit more interesting than this is kind of have another function which would kind of go tree. So what we could do is something like this. That would imagine it would go grow from to tree, something like that. So what it'll do is it'll take the existing tree as input, and then it will extend the tree and return that as output. I'm probably going to restructure that later on, but for now it's a nice enough way of thinking about what our code is going to do. So let's run with it. Okay, so we're going to need a new function. So we've got our grow sapling there, and we've got a new function here that's going to be grow tree, and it's going to be a function. And the thing that I want to do, that I'm going to do in a slightly sneaky move, is think about my tree not so much in terms of the whole object, but rather which parts of the tree are currently growing. At the start, the sapling, there's just one section in our tree. So in our picture over here, this part here is growing, so the whole tree is growing. But what we'll imagine is that there's a set of tips, like of points at the end of the top of our tree that are growing. Like if you don't know this stuff about plants already, plants grow from the tops, they don't grow from the bottom. Okay, so we've got function, we'll call it tips, right? So this is the tips of the tree. And that shouldn't be called grow tree. Well, I'm losing my mind. That should be called grow from. My apologies. Okay, so that function that I'm about to create is going to do something here, and it's going to return a new set of objects, right? So let's just for now imagine this. We'll call this new growth is what I want it to return. I'm going to have to create something inside my function that does that, and then at the very end, I want it to return it to the user. So we'll go return new growth. Okay, not growth. New growth. Okay. So the question is, what do I want to do to my sapling to grow it? Well, let's take whatever the input is, whatever input I send it, and we will pipe that to mutate. So we're going to mutate the tree, right? We're going to have it do something. And what we want to do is adjust all of the different components, right? So where's our little sapling thing over here? So a segment is defined in terms of these 6 variables, and we want to adapt all of them in some way. So the one thing is kind of immediately obvious. If we want to have our tip of the tree, if the next section grows from where the last one ended, in our next segment, its first point is going to be the last point of the previous one. We can express that quite easily within a mutate statement by just saying, well, the old x for our new shoot or branch or whatever is going to be the thing that was new x in the old version. Do the same thing for y. So we'll go, old y equals new y. Okay. All of the others are going to be slightly more complicated, and I kind of don't want to think too hard about this inside this function here. So I'm going to pretend for the moment that I know what I'm doing, and I'm just going to do this. I'm going to go, okay, let's say that the angle is going to be adjust angle from whatever the old angle was. Okay. And I'm going to do the same thing. The scale is going to be adjust scale of whatever the old scale was. So these functions don't exist yet. I'm going to have to write them. These are going to be new helper functions that do some of that work for me. But I don't want to clutter up my nice conceptually simple code here by whatever ugliness goes there. So I'm just going to pretend that I've already written these functions. So then what I can do is say that my new x is going to be adjust x of whatever the old x was. So we're going to take the old x that we've just created over here, and we're going to adjust that in some magic fashion. And so new y equals adjust y old y. Okay, so that covers a big chunk of what we want it to achieve. Oops, sorry. And I think, because in the true tradition of teaching in the time of coronavirus, I have to dash over and deal with some children who are fighting with each other. And since it's been 12 minutes, it's a pretty good moment to break. So I'll come back from exactly this point and we'll talk about exactly what we need to do to fill in these missing pieces and make our tree slightly prettier.